Open your book to page 28. We are starting in lesson 2.5, titled Solving Literal Equations for a Variable. So our first learning target is to solve a literal equation for a specified variable. So they will tell us to solve for x, for m, for w, and so on. Then, probably tomorrow, we are going to use a formula that has already been solved for in order to determine an unknown quantity. So if you had a vocab organizer, we would put these two terms on it, but this year it's a little bit different because we're virtual. So go ahead and just read these two paragraphs in your book. You might need to pause the video to do so. We use formulas in many different areas of our lives. So for example, in geometry, physics, econ or economics, which is money, sports, medicine. These are all examples of where we use formulas, not to mention Algebra 1 as well. So a formula is a type of literal equation, but this is really important here. You might want to underline this. A literal equation contains more than one variable. So it can't just contain two x's. It has to include more than one type of variable. So it could have an x and a y. It could have a g and an n, but it has to have more than one type of variable. So let's go ahead and look at this equation. We are going to solve it. What I would like you to do is write it down in the My Notes section of your book for me, please. You should have extra room. So it's important to note what we're solving for here. We are solving this equation for x. That's important. We wouldn't want to accidentally solve it for b. So what that means is we need to get this 4x term alone first. So in order to do that, we need to subtract b. We want this alone. What's next to it is plus b. So the opposite is to subtract b. Subtract b. These cancel. Now, we can't actually do 12 minus b, so we need to leave it as 12 subtract b, 12 minus b. Don't put them right next to each other. If they're smushed together, it means they're being multiplied, but that's not the case. We're subtracting b. Now, we want this x to be all alone. Currently, it's being multiplied by 4. So the opposite is to divide by 4. Now, on the right side, we need to make one big fraction bar and divide everything by 4. So we could leave our answer like that. X equals 12 minus b all over 4. I'm okay with this answer. Or we could take it one step further. We could do 12 divided by 4 is 3. Then we have this negative b divided by 4, which I can't actually simplify or reduce, so we would leave it as a fraction. So either answer is acceptable. All right, let's take a look at question A. We are solving all of these equations for x, so they make it a little bit easy on us. We don't have to guess what we're solving for. So we want this ax to be alone first. So in order to do that, we must subtract 7. Why? Because this is plus 7, so that's the opposite. So we are left with AX equals, I can do 3 minus 7 because those are both like terms. They're numbers. So do 3 minus 7. We get negative 4. We still need this x alone. Currently it's being multiplied by a, so the opposite, let's divide by a. X equals negative 4 over a, which is my final answer. Now, notice, we're still adding and subtracting from both sides. We're still dividing from both sides. The only difference here is now we have a variable as part of our answer. And both of our answers were actually fractions. So notice how I started with an a and an x. I still need an a and an x in my answer here. Question B, we're still solving for x, but I need this cx term alone first. So let's move this negative 10 to the opposite side, away from cx. So the opposite is to add negative 5 plus 10. Negative 5 plus 10 is 5. I need to cancel out or get rid of this c. Currently, c and x are being multiplied, so the opposite is to divide. Divide, these cancel, and that's my answer. It's not possible to do 5 divided by c, so we're going to leave it as a fraction. Question C. We are going to solve for x again. So we need to get this negative 3x alone first. So in order to do that, I need to get rid of the plus d. So the opposite is to subtract. Cancels. Bring down your negative 3x equals, this is negative 9 minus d. So leave them as two separate terms. I can't push them together. I can't smush them together. I can't actually subtract them. So leave them as negative 9 minus d. I want x all by itself on the left, so I need to get rid of this negative 3, so we need to divide. Those cancel. Make one big fraction bar, negative 3. So our answer is x equals negative 9 minus d all over negative 3. Whoa, that's a lot of negatives here. So we should probably get rid of or cancel out some of our negatives. So let's do negative 9 divided by negative 3. Go ahead and type that in. We get 3 as our answer. And negative d divided by negative 3. The only thing that we can do here is to cancel out those negatives. 2 negatives make a positive, so we're going to change it into a positive d over 3. So again, my problem started with an x and a d. I still have an x and a d in my answer. To check your understanding box, look at question 1. Is this right here a literal equation? I want you to write down yes or no, and then explain somehow in your own words. The answer is no. This is not a literal equation because there's not more than one type of variable. I have an x here and an x here, but those are the same variables. So no, this is not a literal equation. We could solve this question and get x equals a number. X equals an answer. So we are going to go ahead and stop right here for today.